Zeros of a polynomial. A polynomial p of x in one variable x is an algebraic expression in x of the form p of x is equal to a n x raised to n plus a n minus 1 x raised to n minus 1 plus a n minus 2 x raised to n minus 2 plus and so on plus a 2x squared plus a 1x plus a 0, where a n minus 1, a n minus 2 and so on a 2, a 1, a 0 are constants and a n is not equal to 0. N is the degree of the polynomial a n x raised to n, a n minus 1 x raised to n minus 1 and so on a 1 x, a 0 with a n not equal to 0 are called terms of the polynomial, and a n minus 1, a n minus 2 and so on a2, a1, a0 are respectively their coefficients. Let us now understand the zeros of a polynomial. Consider the polynomial p of x is equal to 5x cubed minus 4x squared plus 2x minus 7. Everywhere in p of x, if we replace x by some value, say k, we get the value of the polynomial at that value of the variable, and it is denoted by p of k. Next, everywhere in p of x, let us replace x by 1, and we get p of 1 is equal to 5 times 1 cubed minus 4 times 1 squared plus 2 times 1 minus 7 is equal to 5 minus 4 plus 2 minus 7 is equal to minus 4. So we say that the value of p of x at x is equal to 1 is minus 4, or p of 1 is equal to minus 4. Similarly, p of 2 is equal to 21, p of 3 is equal to 98, p of minus 1 is equal to minus 18, p of 0 is equal to minus 7. Thus, a polynomial takes different values for different values of the variable. Now consider the polynomial p of x is equal to x minus 2. What is p of 2 here? Note that p of 2 is equal to 0. Observe here that 2 is the value of the variable for which the value of p of x is equal to 0, and it is called the 0 of the polynomial p of x. Similarly, for the polynomial q of x is equal to x plus 3, we find that q of minus 3 is equal to 0. Such a value of the variable that makes the value of the polynomial equal to 0 is called the 0 of the polynomial. In general, we say that a real number a is a 0 of a polynomial p of x if and only if p of a is equal to 0. In such a case, a is also called a root of the equation p of x is equal to 0. Let us check whether minus 5 and 2 are zeros of the polynomial x plus 5. Let p of x be equal to x plus 5. Then p of minus 5 is equal to 0. P of 2 is equal to 7. Therefore, minus 5 is the 0 of the polynomial x plus 5. But 2 is not. A natural question now arises as to how do we obtain the 0 of a polynomial. We need to find the values of x that make p of x equal to 0. That is, finding a 0 of the polynomial p of x is equivalent to solving the polynomial equation p of x is equal to 0. Consider the linear polynomial p of x is equal to 3x plus 5 and equate p of x is equal to 3x plus 5 to 0. We get x is equal to minus 5 over 3. Thus, minus 5 over 3 is the zero of the polynomial 3x plus 5, or a root of the polynomial equation 3x plus 5 is equal to 0. We may note here that every linear polynomial has one and only one zero. Can a polynomial have more than one zero? To answer this question, let us take an illustration. Check whether 2 and 0 are zeros of the polynomial x squared minus 2x. Let p of x be equal to x squared minus 2x. Then p of 2 is equal to 0. And p of 0 is equal to 0. Hence, 2 and 0 are both zeros of the polynomial x squared minus 2x. From this example, we understand that a polynomial can have more than one zero. Also, 0 may be a zero of a polynomial, but a zero of a polynomial need not always be 0. Now, let us find zeros of the polynomial p of x is equal to x cubed minus 4x squared minus 11x plus 30, equation 1. To find zeros, we have to solve the polynomial equation p of x is equal to 0. That is, to solve x cubed minus 4x squared minus 11x plus 30 is equal to 0. How do we solve it? Let us write p of x in factored form. Factored form provides quicker access to the zeros of the polynomial. We have p of x is equal to x plus 3 times x minus 2 times x minus 5, equation 2. Now solve p of x is equal to 0, x plus 3 times x minus 2 times x minus 5 is equal to 0. From equation 2, by the zero product property, either x plus 3 is equal to 0 or x minus 2 is equal to 0 or x minus 5 is equal to 0. Thus, either x is equal to minus 3 or x is equal to 2 or x is equal to 5. Hence, minus 3, 2 and 5 are the zeros of the given polynomial. Substitute minus 3 for x in p of x. We find that p of minus 3 is equal to 0. This calculation verifies that minus 3 is a zero of the polynomial p of x. Similarly, we can check that 2 and 5 are the zeros of the given polynomial. Summary. A polynomial p of x in one variable x is an algebraic expression in x of the form p of x is equal to a(n) x raised to n plus a(n minus 1) x raised to n minus 1 plus a(n minus 2) x raised to n minus 2 plus and so on plus a2x squared plus a1x plus a0, where an minus 1, an minus 2 and so on, a2, a1, a0 are constants and an is not equal to 0. A real number a is a zero of a polynomial p of x if and only if p of a is equal to 0. In such a case, a is also called a root of the equation p of x is equal to 0. Every linear polynomial in one variable has a unique zero. A polynomial can have more than one zero. Factored form provides quicker access to the zeros of the polynomial.